Hello everyone, now let's solve this problem. So a flat plate of area 1.5 into 10 raised to the power 6 mm square is pulled with a speed of 0.4 meter per second relative to another plate which is located at a distance of 0.15 mm from it. So in this means that this is a plate. Okay, so you can assume it like a plate as a 3D version. So from here you can just see the front view. So this is the fixed plate. You can see this plate. This is the fixed plate, right? And relative to this fixed plate, you have got a moving plate which is at 0.15 mm, right? And it is being pulled at zero point 0.4 meter per second relative to this fixed plate, right? And you have got fluids in between the two plates. And now you are asked to find the force and power required to maintain this speed, the speed of 0.4 meter per second. And if the fluid separating them is having a viscosity as 1 poise, right? So this means that you have got a fluid in between them which is having a viscosity. Definitely it is a dynamic viscosity and it is 1 poise, right? So now let's write down the given parameters. The area is given as, area of the moving plate is given as 1.5 into 10 raised to the power 6 mm square, and as 1 millimeter is equal to 10 raised to the power minus 3 meter, so it will become, if you just convert it, 1.5 into 10 raised to the power 6 into 10 raised to the power minus 6 meter square, so you will just end up getting 1.5 meter square. I have just converted this entire data of area into SI unit of meter square, right? Now the speed of this plate, right, the speed of this moving plate relative to the another fixed plate is 0.4 meter per second, right? So I will say that this is my du. Okay, du is the speed of this moving plate relative to this fixed plate. So this is du. Simply I'm just writing du 0.4 meter per second, right? And what is the distance between the fixed plate and the moving plate? That is dy, and it is clearly given in our equation as 0.15 mm, 0.15 mm. And what is the dynamic viscosity is given as mu is equal to 1 poise. And if you just convert it into Newton second per meter square, 1 over 10 Newton second per meter square, right? You just need to divide the value of poise by 10 in order to get in the SI units of Newton second per meter square. Now you know that from the Newton's law of viscosity, tau is proportional to du dy, which is the velocity gradient, right? So you can write it like this: tau is equal to mu du dy, right? So this is my formula, in which this is the formula that we know, right? So if you just put the value of mu as 1 by 10 and the value of du as is given, right? Du is given as 0.4 and dy is given as 0.15. So if you just calculate it, right, 0.15 mm is given, so you need to convert it into meter. So 0.15 into 10 raised to the power minus 3 meter, right? So just convert it, 10 raised to the power minus 3. So now if you just calculate this, you will end up getting 266.66 Newton per meter square, right? So this is the value of tau, right? This is the tangential stress. Now if you want to find the force, right, according to your question you were asked to find the force at first. So what is going to be the force, and then you need to find the power, right? So what is force? Force is equal to, right, you know that tau is equal to force upon area, and here in this case the force will be also tangential force, right? And this upper moving plate is also being pulled by the tangential force, right? So if you just calculate the force is equal to tau into area, where you know the value of tau, right? The value of tau is already here, and if you just put the value 266.66 into area, the value of area is 1.5, 1.5, right? 1.5 meter square. So if you just calculate this, you will end up getting the value in Newton, right? So the force, the value of force is equal to 400 Newton. If you just use the calculator, you will end up getting this value, right? And now what is the value of power? Power is equal to, F into U, right? Power is equal to F into U. Here U is the velocity. Now how? Let's see. F, the unit of force is Newton. The unit of U, which is velocity, the unit of velocity is meter per second. Meter per second. So Newton into meter will further give you joule per second, and joule per second means work per unit time, right? So it will actually give you the equation for your power, right? So ultimately joule per second is power. So that means you will get power by multiplying force into the velocity. So power is equal to force into velocity. Here the value of force already calculated as 400, and the velocity is also known to you, which is 0.4, right? So 400 into 0.4 will give you as 160. Now let's solve problem number 5. So in which the statement says to determine the intensity of shear. So you need to figure out the value of the shear stress, which is tau, right? And of an oil, okay, of an oil. Oil is also a fluid having viscosity as 1 poise, right? So you write the given data as mu. Mu is 1 poise, and you know that 1 poise is equal to 1 by 10 Newton second per meter square, right? Where Newton second per meter square, this is the SI unit, right? SI unit is Newton second per meter square, right? This is not poise, so you need to divide the value of poise by 10. Okay, now the oil is used for lubricating the clearance between a shaft of diameter 10 centimeter and its journal bearing. See, this is the shaft, okay? This shaft is having a diameter of 10 centimeter, right? And this is the journal bearing, and this journal bearing is definitely fixed. And this shaft, the shaft is definitely moving, right? So the upper plate of the shaft is definitely moving, and the distance between the fixed plate and the moving plate is given as 1.5 mm, and the shaft is rotating at 150 rpm. This is rotating, right? This is rotating at 150 rpm. Okay, so now see, we have written the given values. Mu is written, diameter of the shaft is written, and as you need to figure out the value of tau, what do you need? You need the value of mu. Mu is already given. Du, change of the velocity between the shaft and the bearing, right? This is the change of the velocity between the shaft and the bearing. So we know that the bearing, this journal bearing, this is fixed. So that means it will have its velocity as 0, right? The journal bearing will have its velocity as 0, but the shaft will have a velocity, and that velocity should be tangential, right? You need to figure out the value of the tangential speed, okay? Because you want to put the value here, and as this is tangential stress, you need the tangential speed, the value of the tangential speed. What is the tangential speed? When you know the value of the rotation per minute, which is n, and you also know the value of the diameter, so you just simply do this, that pi dn by 60. Okay, so this formula will give you the value in meter per second. See, here I have written why you use this formula, multiplying the circumference by the number of revolutions. Pi d is the circumference. So circumference into number of the revolutions per second, right? So this is number of the revolutions per second, n by 60. This is number of the revolutions per second, and pi d is the circumference. This will give you the tangential speed. Okay. Now see, using the equation which is known by the Newton's law of viscosity, which is tau is equal to mu du dy, right? Where du dy is the velocity gradient, mu is the dynamic viscosity, tau is the tangential stress, right? Now du is already given as u minus 0, because this is the change of the velocity between the shaft and the bearing, and if you just put all the values here, you will end up getting your desired answer in Newton per meter square, because you are figuring out the value of tau. Tau is the stress, and stress will have force upon area, force, where this force is tangential force,